All right, folks, we are going to get started on a lecture on chapter 5 here, which is how to code control structures. And because there's literally so much in this chapter, we're going to break this up into 2 lectures. And I always like to start with a conversation around why this topic is important. Control structures are things such as if statements. Like you've probably heard of if, else, or in other languages they call them if, then. And so that's one kind of control structure, is an if statement. And then there's also things called loops, like for loops and do while loops. And so just from a category, like both if statements and loops are considered to be control structures. What are control structures? Control structures control the flow of execution. And so, right now, what's the flow of execution? The flow of execution right now is start on line 1, go to line 2, go to line 3, go to line 4, and kind of go top to bottom. So you would say that the flow is sequential, top to bottom. And then it's also somewhat event-driven. And so if you click a button, it still is a sequential flow, top to bottom, but it might just be like, let's start on line 5 and go to line 6, 7, 8, 9, 10. But right now the flow is sequential, and these control structures will modify that. No longer are we just going to be following our code, from top to bottom. Now the execution of our code is going to be controlled by some sort of coding structure, by some sort of coding block that we're going to learn, a block of code. And so when you think about control structure, it does exactly that. It controls the flow of execution. Why is it important? Well, there's a lot of reasons why these are important. I would argue the first thing is that this is the most fundamental pieces of coding that there are. So this is a building block. This is foundational to any programming language I've ever studied. Okay, so my personal journey of learning to code dates back to the 90s. And in the 90s, my first programming language was C++. And I learned these control structures in the 90s. So it's been around since I've ever studied it. Now, I never studied on punch cards. If you talk to some folks that are older than us, maybe they would tell you, they coded with punch cards, which were cards where you punched holes in them and you fed them into the computer. And that's kind of like the first form of giving a computer instructions was on paper, and it would read the holes on the card and interpret that. I've never done that. Well, you'd have to ask somebody. Do if statements exist on punch cards? I would bet they do. Point is, these are foundational. They've been around forever. So very foundational. But more than just like, hey, they're in everything. They're in C++, they're in Java, they're in JavaScript, they're in C#, they're in PHP, they're in every language just about, right? So they're foundational, they're in every language. But more, what do they do for us, right? So I would answer the question, why is this important, by saying they're in every coding language, they must have some importance. But I would also say 2 things, and I've said this every semester since I've taught this, because I think they describe what they do very well. If statements make your programs smart or dumb, but let's just go with smart, because that's the optimistic way of looking at this, right? So you want to build applications that are smart. And that's what if statements do for us. Okay, and I'll dive in deeper what I mean by that. But if statements make your programs smart, or you can look at, if you're a pessimistic person, you can say it could make them dumb. So if you code good if statements, your programs become smart. Or if you code bad if statements, your programs could be dumb. Right? But that's optimist, pessimist, half full, half empty kind of conversation. Loops then, right? Loops, which we'll cover tomorrow, right? So why is this important? If statements make your program smart, loops make your programs powerful. Okay? And what I mean by powerful is that you can code a small block of code and execute that thousands of times if needed. Right? So what you're getting out of a loop is a whole lot of functionality. It's doing a lot of work. Loops do a lot of work without having to write a lot of code. Okay, so again, it's always important to, in my opinion, to understand why these things are important. And I would answer that question in that way. It's important because, look, they're foundational. They're in all these coding languages. Look, if it's in every coding language that exists, it's probably pretty doggone important. The other thing is that it makes our programs smart and powerful. And those are very, those are attributes that I would want the software that I write to have. Okay? So every software that's out there, I can almost guarantee you without even looking at it, right? Every software that's out there, Facebook, whatever, Microsoft Excel, Twitter, whether it's a web application, Amazon, whether it's a desktop, all your favorite video games, they all have this stuff. Every piece of software ever written in your lifetime that you've used has had this stuff. So if that's not an important enough reason to learn them, I really don't know what it is. Now, I'm going to start by just writing a little bit of code. Okay, and so I'll kind of come back to the slides. You guys aren't really here to hear me read from a slide anyways. So we're going to start with, again, these are called control statements. And the first kind of control statement is an if block of code. Okay, now we're just going to basics here. Okay, so if this is like roll your eyes in the back of your head easy, then that's great. If you've never seen this before though, we're going to start very slow. Okay, so if statements. If statements allow us to run code conditionally. What do I mean by run code conditionally? Well, as humans, we make decisions based on conditions every day. Think about that. As humans, we make decisions based on conditions every day. These decisions are either smart or dumb. Dumb, okay? Or somewhere in between. Let me give you an example. This morning, I decided to wake up to an alarm and go to work based on a condition that I earn a paycheck. I like my job, I like you guys, but I probably wouldn't be here if I wasn't getting paid. Right? So there's other conditions, as an educator, I'm coming here to educate. I'm coming here to teach. But ultimately, I'm probably here because I get a paycheck. That's my ultimate incentive. I mean, I like this stuff, but yeah, anyways. You get my point. I made a decision to wake up to an alarm clock to come here and earn a paycheck. Now, I could have decided, and that's a smart decision, I would argue. Maybe other people disagree, but that's how I view that scenario. I could have decided to turn off my alarm clock and roll back over and go to bed. And then if I did that enough, I'd probably lose my job and I would no longer earn a paycheck. So that wouldn't be so smart, right? So as a human, I decided to do something based on a condition. And we do this every day, whether we're even realizing it or not. We're making decisions to do things. You know, I'm going to decide to eat a salad based on the condition that I want to lose weight, right? I'm going to make a decision to learn a foreign language based on the condition that I can communicate with people in that other language. I decide to, whatever it is, okay? So, if statements allow your code to do the same thing. Allow us to run code conditionally based on based on what's called a Boolean expression. A Boolean expression just means something that evaluates to true or false. This allows our code to be smart. So if I were to take the condition as a human that I described, maybe I would make a Boolean variable called earn paycheck equals true. And I could say if I want to earn a paycheck, wake up and go to work. So notice, okay, let's again, we're starting slow. Notice what's inside of the parentheses. What's in the parentheses, what's in the parentheses is my Boolean expression. Let me auto-hide that. A Boolean expression has to evaluate to true or false. Evaluate meaning that it needs to end up as a true or false. Now, earned paycheck happens to be a Boolean variable, so it's very easy to tell if it's true or false. There's really there's not much evaluation going on here. It looks at the variable and determines if it's true or false. Because this is true, because earned paycheck is true, I'm just going to do another console write line out here. And then this is thanks for using my program. Because this is true, what is inside of the curly braces will run. And you can see I get two write line statements. It says wake up and go to work. Then it says thanks for using my program. Now, it's important to say this, only what's inside of this block of code here. This block of code here executes based on the condition of my if statement. So if this if statement is true, it runs this block of code. If it's false, it does not run this block of code. This line here, line 17, does not execute conditionally. Line 17 executes no matter what. It's outside of my if statement. So if this becomes false, meaning I don't want to earn a paycheck, only line 17 will run. So line 17 is not in an if statement, so it still executes sequentially top to bottom. Okay, so this is an example of an if statement, and this is an example of controlling the flow of execution through my program based on a Boolean expression. Because this variable is Boolean, it's going to either be true or false. You can't store anything else in it. You can't store a number. Okay? However, many times in our programs, we might not have just a Boolean variable inside of our if. Now that's another name for this, is another name for putting a Boolean in an if statement. I'll just add this note. Another name for a Boolean variable inside of an if statement is a flag. Okay, that's just a flag, meaning it's on or it's off, true or false. So it's just another name for it. You heard this variable is called a flag, right? It's just another name for it. But sometimes you need to evaluate a condition, right? So if you're not using a flag variable like this Boolean variable, let's use another one. This is the one that I like to use all the time. I'll say double salary is 100,000. Okay, so I have someone's salary is 100K, right? 6-figure job. If salary is greater than, make up a number. If salary is greater than $40,000, then we'll write you are a high income earner. So we're no longer using a flag or a Boolean variable. Instead, we have this operator, which is greater than. And that operator is being used to test a condition. Okay? In order to test a condition, meaning, hey, is this true or false? It's a Boolean expression. It has to evaluate to true or false. You can't put something in there that does not evaluate to true or false. It has to evaluate to true or false. Okay? And because salary is either going to be more than 40K or it's not going to be more than 40K, line 15 executes conditionally. And here, again, you might be able to guess. These are the two outputs. You're a high income earner, and thanks for using my program. If I move this number down to 10,000, we no longer get you're a high income earner. Now, I'm going to mention this here because I think it took me a couple of tries before I realized that you do not have to have an else block of code. An if statement, as I've demonstrated, can exist by itself. It doesn't have to be more complex. It could, in theory, just be an if statement. And if this is true, then you want to do these things. So when you're learning this, the first thing to learn is an if statement, can exist by itself. It doesn't have to be more complex than this. I think so often is we move so fast through these concepts, that we think that an if has to be an if, else if, and nested ifs and all this kind of craziness, but it depends on the problem that you're trying to solve. When do you use an if statement? Is when you're trying to solve a problem in the real world that's based on a condition. So the problem you're trying to solve is solved based on a condition in the real world, then you're going to try and solve it in code with an if statement.
I have a question.
Yeah.
Can you have multiple methods inside of one flag?
Can you have multiple methods inside of one flag? So what do you mean by method? Because we haven't really talked about methods yet.
So you could run both console.writelines inside of that salary.
Yeah, okay. So you're talking about line 15 being a statement, yeah?
Yeah, yeah.
Yes, you could. So let's talk about that. I'd say console write line, congrats. So the question is, can I have multiple statements inside of a block of code? The answer is yes, and here's a demonstration of that. Here, because we're not a high income earner, if I add a couple zeros, then you'll see the output there. Now, great question. Let's expand on that. If you only have one statement, now you see now I've got multiple statements. If you have multiple statements, these curly braces are mandatory. Okay? You might see this condensed down that if there's only one statement, okay? If there's only one statement, so let's pretend like we don't have that. For the purpose of condensing code, when there's only one statement, you might see it something like this. So line 13, this statement still executes conditionally based on this, and as a demonstration, you see this will function the same way, right? And that this statement executes conditionally, right? So you might see this. It works the same way. For beginners, I recommend putting the curly braces in all the time, because we're really just learning it for the first time. So go ahead and put the curlies in. Okay, but it is worth mentioning that if you have multiple statements, the curlies are mandatory. If you only have a single statement, then they're optional. And that single statement would still execute conditionally, meaning based on the condition in your if statement. Now, slide 4 talks about all the different ways that you can evaluate conditions. Is the salary equal to something? Here's the biggest mistake. Notice this equal. How many equal signs do we have? I'm literally going to ask this 10 times. How many equal signs are here?
2.
That's one time. 2 people answered me. How many equal signs are here?
2.
How many equal signs are here?
2.
How many equal signs are here?
2.
I've lost count. How many equal signs are here?
2.
So when I put this inside of an if statement, how many equal signs do I put?
2.
Are you sure? Yes, you are sure. Let's talk about, well, in JavaScript. In JavaScript. So if salary is 1,000, inside of an if statement, we test a condition. To test to see equality, you use 2 equal signs. All right? When you're testing for equality, when do we use 1 equal sign? 1 equal sign is assignment. You are setting salary equal to 1,000. 2 equal signs tests for equality. You're asking, does salary equal 1,000? Okay? So there's a difference between 2 and 1 equal sign. Josh pointed out, hey, in some languages, they allow for 3 equal signs, but here you can see that C# is not one of those languages. For example, if I do if salary is 1,000, even this won't work. It notices you got a double here and a string here. So it's going to kind of force you to have the same data types, which is the difference between the 2 and the 3. Okay, so we already saw the greater than. Safe to assume there's Greater than and less than, right? Think of the alligator teeth that you learned in 2nd grade, right? Which one's bigger than, less than? Inequality is the not sign, not equal to. So I would say, okay, here, if salary is 1,000, your salary is 1,000. There you go. So this is testing for equality. It's the double equal signs. What about not equal to? You would say your salary is not equal to 1,000. Well, of course, it is 1,000, so that's not going to spit out. So let's just say salary is 1,001. If salary is not equal to 1,000, now we get the output. Your salary is not 1,000, right? Because no, it's true. Boolean expression has to evaluate to true for this to spit out. Less than and greater than. We also have greater than or equal to. Greater than or equal to. So is 1,001 greater than or equal to 1,000? Of course it is. Your salary is 1,000 or more. Right? We got tax season coming up pretty soon, right? Do you think if statements are inside of TurboTax? Absolutely. Less than or equal to. So that's what these relational operators are used for. Relational operators are used inside of if statements to help you evaluate an expression to Boolean, true or false. Here's a bunch of examples of comparing strings. You're checking for empty strings, checking for null. I like, and I demonstrated this yesterday, string first name equals, like if you were to say null, instead of using this if the message is null, which is totally fine, I prefer if string dot is null or empty first name. Okay, that checks against both empty string and nullness. Right? So this is also a useful method that you could put inside of an if statement. This returns true or false. So Vinny, I think you were asking about methods inside of an if statement. This is an example of putting a method inside of an if statement. The method is called is null or empty. It's a utility method that belongs to the string class, right? So you could say string class dot notation is null or empty. And check this out. Dot is null or empty. When I highlight this, you can see this word right here where it says bool. You see this word right here, bool? That means that the method returns bool, returns true or false. So by looking at what this is called is the method header, by looking at the method header, I could tell it returns true or false. And then I would say name is empty. So here, first name is null. This should return true. Name is empty. If I put it null, of course, if I do empty string. Ryan, what's up?
Are there else ifs and?
Yeah, we're getting there. Yeah, we're getting there. One step at a time, though. Helpful? Definitely got to take this one slow. Question was, are there else blocks? And the answer is yes. There are if else. And then if else if all these kinds of things. Okay. I think you could read through these examples now and understand All of these can go inside of an if statement. All of them can be used to evaluate true or false. And because they evaluate to true or false, they control the flow of our code. That makes our code smart if we code it in a smart way. It can also make our code dumb if we don't code it correctly. We are back from a quick break. Now, in our code thus far, we've kept it simple, which is good for starting. As I mentioned earlier, what we're doing here is we're solving real-world problems, sometimes that have never been solved before, right? I mean, self-driving cars, right? That doesn't really exist, and there's Tesla trying to solve that problem. You could call it problem solving or opportunity discovery, right? So, again, how do you look at it? It's a new opportunity. It's a problem that's never been solved. We're trying to make cars drive themselves. If there's a stop sign, car stops. If there's a person, car stops. If-else statements at the root of all this software. But what I'm getting at is that not all problems are easy to solve, especially problems that have never been solved before. So it would be great if we could, if stop sign equals true, this is kind of how if stop sign, if Boolean, if stop sign, Tesla goes stop. Right? If stop sign is true, it'd be wonderful if all the software in the world was this easy to solve. But what I'm getting at, it's not, right? So problems are more complex than simple if statements. The more complex the real world problem, the more complex our if statements become. And so as they become more complex, we had a salary, right? If salary is greater than 40,000, let's say someone's age, we'll make their age a whole number, and let's say they're nice and elderly, 110 years old. So if salary is greater than 40K and age is less than 100, we'll say employable. Just making something up here, right? So you have to, well, let's just say we're trying to find someone on the cheap. So you're coming to our company, you have to have a low salary less than 40,000, and you have to be less than 100 years old. The point being is this if statement is now more complex because we're evaluating two things here: salary and age. This is called a logical operator. And if you've ever studied electricity, without a doubt, you've probably studied what are called gates. And gates control the flow of electricity, and that's where, there's AND gates, there's OR gates, there's exclusive ORs, and all this kind of stuff. And that's really where this is really what's going on in your computer, at the board level, is that we're controlling the flow of electricity using gates. Programmatically, though, it's controlled with these symbols. You'll notice there is a single and a single or. Now, by the way, so this is what's called a short circuit and operator. Okay? Short circuit is a 80s movie about a robot, but it's also, remember that one, right? Yeah. It's also a way of saying, hey, okay, both of these have to be true for the overall to be true. So what's on the left has to be true, and what's on the right has to be true for the overall expression to be true. So short-circuiting means if this is false, do we even need to look at the right? No. If salary is not less than 40K, we don't even need to look at the right. The right does not need to be evaluated because if the left is false, we could just skip the right. That's the short-circuiting. We're skipping. So what does that do? That gives us like a tiny fraction of a second more efficiency because we can skip an evaluation of something. Okay, so this is a short-circuiting operator. This is the AND operator. You hold shift, you press the number 7 on your keyboard. That's an ampersand symbol. There's 2 of them. Technically, there is a single AND, but we're not going to use a single AND. We're always going to use the short-circuiting, okay? Because we want to, slightly more efficient. Milliseconds more efficient, okay? The other one is an OR operator. Now this is on the enter key. This is called the pipe symbol, right? There's a single OR, but that's not the short-circuiting OR. We want to use a short-circuiting OR. So it's above the enter key. You hold down shift and press that key above the enter key. That's the pipe symbol, and you use 2 of them. Now the way the OR works is the left or the right has to be true for the overall to be true. So only one or the other. Okay, so how does the short-circuiting work here? If the left is true, again, we don't even need to evaluate the right because the overall would be true. Okay, so again, it's slightly more efficient to use the short-circuiting OR operator. All right, so here we're now looking at 2 things. And this is a nice and readable block of code. The salary has to be small, so we'll say the salary is $1,000 and the age is 90. We'll get the output of employable. As you might anticipate, you see that they are employable. What if the salary is high? Is the overall true or false?
True.
The overall is still true because it's an OR. Because it's an OR. Right? So if I run that, we still see employable because it's an OR. Now what if I change this to an AND? Now is the overall true or false? False. Now the overall is false because of what? Because the salary is not less than 40K. And so you see it does not say employable because the overall is false. Ryan?
And then, can you have multiple ORs or multiple ANDs?
Yeah, you could have multiple, yes. And there is an order of operations kind of left to right. However, I'm going to dive deeper onto the order of operations when you have multiple because it's not always that simple. So I need to dive into that a little bit deeper. All right. Now, if salary is less than 40K and age is less than 100, this could be written a different way. Not to, if you can write it like this, this is the preferred method. Okay? If you can write it all in one concise block, sometimes you can't. And I'll get into why you can't. But another way of writing this would be with nested if statements. If age is less than 100, okay? So functionally, this is the same as if salary is less than 40K and age is less than 100. So what is this called? This is called nested if statements. Wait a minute. So you're telling me you could put if statements inside of if statements? Yes, you could put if statements inside of other if statements. And just like the name sounds, it's nested, right? It's just what it is. It's one thing inside of another. Like, what's that China doll, nested China doll thing? Whatever. You know, smaller dolls and whatever. Okay.
The Russian dolls?
Yeah, what are they called? Russian dolls, not China. Excuse me.
Nesting dolls?
Russian nesting dolls, yeah. Excuse my ignorance. Cultures are completely wrong. Yeah. Okay. Now, if you're wondering why might you do this instead of an and, when would you do this nested instead of an and? Yeah?
Well, I mean, if you wanted to make sure, say, if you want the salary less than 40,000,
Yeah.
but then you wanted other
Mm-hmm.
options. For,
That's
if they're
right.
Under 100, then you do this, and if they're over 100, you can do that.
So when the scenario is more complex, you need more coding paths. And so for more complex scenarios, let's break that down. Let's simplify this down. We'll come back to the more complex scenarios. So far we've only been operating with if statements, and we kind of left off with something like this. And age is less than 100. Okay, we know that what's in the if statement is the true block, meaning the code that you execute based on this condition being true. There's also a false block. Else is the false block. You don't have to have an else, but sometimes you want code to execute. What happens when this condition is not true? So it depends on what your needs are for the software. If your software needs to run code based on something being true or something else being or that being false. So here we say employable, and maybe this is just letting the person know you're not employable. Right? So now if this is true, we tell the person you're employable, otherwise we say you're not employable. So you got to be cheap and you got to be less than 100 years old. Debug. Now what's the outcome here? Well, they make too much money. Right now, they make too much money, so they should get the message, not employable, and that's what you see here. So this runs because this is false. So else is the false block. So it really comes down to what you need your software to do. Do you run code just on something being true, or do you run something else based off of it being false? In this case, it's kind of like a coin, It's either one or the other. You're getting one output or the other. You're getting heads or you're getting tails. So else is your false block. Where this could get more complicated now that we understand there's a true block and there's a false block, you could associate another true block with an else. Okay, so very simply, you can't have an if by itself. You can have an if else by itself. But let's just focus on salary. If salary is less than 10, very employable. Else if salary is less than 30, we'll say employable. else, notice my final else, there's no if. My final else is always the false block, meaning nothing above was true. Everything above has been false. And we're running the else block because everything above was false. So else is always the false block. Now we're saying, hey, if you make less than 10, you're very employable. If you make less than 30, you're just employable. Else, neither of those were true. Counsel.writeLine, not employable. You make too much money. And so here's 50. They should, in fact, get not employable because they make too much money. We change that to maybe 25. We're just employable. Else, if you're just making, for example, if you're just making 5,000, we should see that you are, in fact, very employable. Yeah? Now, this is kind of like, this structure right here is kind of like a three-sided die, right? You're getting one of three outcomes. That's kind of an important thing to realize. You're getting one of the three. You're not getting multiple outcomes. You're just getting one of the three. You're going to roll the dice and you're getting one of the three. So far, so good? So where I was getting at earlier is if we bring age back into the equation, we could say if age is less than 100, now we could say counsel.writeLine very employable. We could do an else in here, counsel.writeLine we can't employ you because of your age. As if you're too old. You might get sued, but you know. Age is one of those things that you can't tell people you're not hired because of your age. It's a protected category. So let's not really build this software because we'll get sued and we'll lose our jobs. But now you can see the salary's in range. If the age is in range, you say you're very employable. But if the salary's in range and the age is not, we give them a different message. Right? So to Josh's point earlier, when might you use nested instead of logical operators like ands is when you have more outcomes that you need to evaluate. And so here, age is 90, salary is within range. We should see very employable. And there you have it. But if we all of a sudden say that you're too old, we get this, we can't employ you because of your age. So I've demonstrated if else's, if else, and nested. So there's a lot of concepts, and I'm not delusional. I know for you to learn this, you got to practice. That's what the labs are all about. Okay, so this is part of learning, but it's a small part compared to the much more important piece of actually doing this. Much more important to actually do this. All right, they give some examples of logical operators. I've done that. They show you an if, else. Notice this syntax here. Couple things worth noting. On my if statements, there are no semicolons here. Beginners make that mistake. Okay? Don't put your semicolons after the parentheses. There's no semicolon here. Common mistake. This syntax here with the brackets, that just means that's optional. Like an if statement does not have to have an else if. So else if, means optional. What goes inside the parentheses is a Boolean expression, something evaluates to true or false. The else block is your false block. And if you have multiple statements, the curly braces are mandatory. Notice, as I said earlier, with a single statement, you don't need curlies. Curlies are, of course, these right here. All right. If you have multiple statements, you need curlies. Here's an if-else. Here's an if, else if, else if, else. Right? I look at this and I see a four-sided die. Right? You're getting one of four outcomes. You're not getting two outcomes. You're not getting zero outcomes. You're getting one. And you got four options that's going to roll. One of four that it will roll. Right? Here's the first one. Here's the second one. Here's the third one. Here's the fourth one. When your code hits this, you're getting one of four outcomes.
I have a question.
Yeah.
So on the else ifs,
Yep.
If the first one is true, it won't even go down to the else ifs, right?
That is correct. If the first one is true, you're done. It executes this line, and then it jumps down to the bottom.
So
The flow skips the rest.
you'd want to code that in a way where it's going to be like, okay, it does 100, then 200, then 300
Yeah.
in the way that you want it.
If you can code it in such a way that the most likely outcome is first, then code it that way because that's the most efficient.
Right.
I have a question.
Please.
So in our example, we did if else, and we did age first, and then we had else if. Aren't you supposed to do else last? Is what you're saying?
Yeah, the final else. Now, else, yes. So else is the final block. But notice that this else is associated with that if. In fact, if I highlight this else, it highlights the if that it's associated with. So I've indicated that by tabbing these over, but also the else block is associated with this if. This else is associated with this block of code. So you can even click it and it'll show you like which ones they're associated with. So it might be confusing if you say else is going to be the last. Well, else is not the last because here on line 19 it's associated with this if. This else is associated with this if, but it is the last in the block that it's associated with. Does that make sense?
Yeah.
Cool. I thought that was too wordy, but I'm glad it made sense. But yeah, it does help to in Visual Studio make sure that the else's are associated with the correct ifs. And you can tab things over and that'll help, but really you got to click to see to make sure you're not missing anything. So here's nested ifs. We demonstrated that. Okay. And then now we're on to this other thing. So that's your if statements. There's a lot there. Okay, so if you're a beginner, intermediate, there's a lot there. Especially if you're a beginner. Okay? So the next thing to realize when we're going to learn this other thing called switch. What a switch statement is used for is basically a replacement. Switches can replace, when you have a lot of if else ifs, I'll make up int age equals 5, okay? If age equals 1, how about if age is 0? You are a baby. Else if age is double equal sign. How many equal signs inside of this? 2. Council dot right line. You are a toddler. Else if age equals 2. You are an infant. I'm running out of else if age is 3. You are a I'm out of language for little ones. You are a
Small human.
a small yeah. You are a very small human. I'm a very small human. Human. Else you're a human.
You're an adult.
You're an adult, yeah. Else, welcome to adulthood.
That's true at Disney. If you're, was it 10, over 10, they charge you as an adult.
Yeah.
Disney's incredible. I've heard their prices have just been
They have
astronomically through the roof. Okay. So jokingly, we could say anyone that's 3 or that's not 3 is an adult. Okay, so we're just, as you might guess, because the age is 5, we give the message of welcome to adulthood. Okay, and so if I change this to 0, as you might guess, you are a baby. Okay, so we've got this if, else, if, else, if, else. Again, this else is our false block, meaning none of the above if statements evaluated to true. Yeah? We all got this. This is what we've covered so far. Okay? Now, learning to code this, okay, this is a simple example. Learning to code this, there's a learning curve too. Okay, so there's a learning curve to learning this. You guys have started that journey of learning curve. Okay, so you're somewhere on the curve. I don't know where, but you're somewhere on there. These statements, though, I mean, just looking at this simple example. Okay, this simple example, I've coded 30 lines of code. And learning it, and then also let's just say you haven't seen this before, sitting down and understanding it takes a little bit of okay, you got to look at line 9. If age double equals 0, we do one thing. Else if age double equals 1, you do something else. Else if age double equals 2. So they're not the easiest to comprehend quickly, right? So they're not. This is a simple example, so it's not super hard. But these if statements, they can be very complex. They can be very, very complex. And so they make a simpler structure than this, okay, to replace this. And they say, okay, yeah, there's probably a better way. Is basically where it gets at. So now what we do, what are we analyzing here? We're analyzing age, right? We are inspecting the age variable, and based on the age variable, we're doing something. And so they make this thing called switch. And notice what we're switching on. We're switching on the age variable. So this switch structure is going to be used to replace this if, else if, else if, else if, else block. And it's going to be a slightly more condensed syntax. So it's going to be shorter. And upon looking at it quickly, you can understand it more quickly. So there's a learning curve to the switch structure. And so you got to learn it. But then once you learn it, you'll be able to analyze code faster using it. And so we're going to say case 0, which is essentially saying age is 0. What did we do for 0? We said, you are a baby. I'm going to put the keyword break. I'll explain what that keyword does. Case 1, what did we do for 1? Console.writeLine, you are a toddler? Break. Case 2. You are an infant? Case 3. You are a small human? Right, so we did 3. Remember the else block was if none of the above if statements were true. If none of we did else. In our switch, it's not called else. In our switch, it's called default. Default. You are a welcome to adulthood, we said, right? Okay. We have replaced this coding structure with functionally equivalent switch. And age 0, it'll say you are a baby. Debug, start without debugging. You are a baby. Okay. What does the keyword break do? This exits the switch. Okay. So once you hit a break, you go to line 27 and you say, thanks for using my program. So the break exits the switch. In C#, breaks are mandatory for any case. So the case, again, we're evaluating age to 0. If age is 0, we run case 0. Breaks are mandatory. You notice if I didn't put a break here, it says you have to have a break. In other languages, that's not the case. In other languages, you could have what were called fall-throughs. But in C#, that's not a thing. You gotta have breaks. Okay, so notice I said switch statements can replace keyword some if, else blocks. Here's my if, else block. Here's the switch that I used to replace it. Notice I did not say every if, else block. Switch statements cannot replace if, else blocks when they test for ranges. What's a range? Example. If age is less than 100. That's a range. That's a bunch of numbers, less than 100. So there is no case less than 100. That doesn't exist. Right? That breaks some stuff. So, yes, question.
So then, would you only like use if, else's, and then the switches just like differently whenever you choose, like for whatever problem you're trying to
Yeah, you know, if it uses a range of values, that's easy. You got to use if else is. Like, if you're testing for a range of numbers, it's got to be this.
So it's kind of like in JavaScript, we did like the loops, and you could use different loops for different things.
Yeah, for different purposes. Yeah, switches. Yeah, if I think about some use cases for switches, like a menu system. Press 1 to open Notepad. Press 2 to open Word. Press 3. So you're allowing the user simple single number inputs, and then you're switching on that input.
Could you add another
I have a
variable to
question.
that? It wouldn't work.
The question is the first. I'll be right with you there, Vinny. Can you add another variable?
So you're not necessarily looking for a range, but you're also looking for.
Yeah, you know, believe it or not, like if you wanted to say if salary, let's see, I don't know. There is no salary. I believe because your cases. So yeah, you can do little tricky things to make them more complex. Like you could do, so that would be another way. Now, can you do if age, switch on age and salary? No, I don't think so. Double salary. It's a good question. I've never even tried it, to be honest with you.
That's more so what I was wondering.
Yeah, no, there is no that. Nors, same thing, right? Got to switch on a single variable. That variable can be an int, like I demonstrated, but it could also be like a string. Like let's just say string name equals Evan. Let's switch on name, and then it would be case Evan. Cancel that right line. Hello, Evan. And then all your cases become strings. Josh, Daisy, Sam, so you can switch on different data types besides ints. I don't know who you are. Right, so case Evan, so debug, start without debugging. We get hello Evan, right? Because the name, switch on the name, case Evan. So that's the next thing you gotta realize is that the data types you switch on can be ints or strings or doubles, but your cases have to match the type. You had a question, Vinny.
Yeah, I was just gonna ask, like, are switches only really used for like small number things? Because this seems pretty like tedious.
Tedious?
Like you wouldn't use this for something like real, like a large range of numbers.
They are, yeah, because when I give the example of like a real world use case, I think of menus. That's you know, simple decisions, I would say, right? Simple decisions. But what you're leaning towards, and I would agree with, complex scenarios probably lean towards an if-else if block.
Because you wouldn't want to go and like code 1,000 different cases, but
Yeah, no,
maybe
exactly.
you might need to, but
Yeah, if you have a range like less than 1,000, then you would just say in an if statement, if the number is less than 1,000. You wouldn't want to say case 0, case 1, case 2, case 3, case 4, case 5.
Right.
Yeah, and then they all do the same thing. So here they're switching on a string. And in case the string is R, you do one thing. If the case is C, you do something else. Otherwise, default, remember default is your else block. Nothing above is true, so then you run default. Okay? Now you actually, just like on an if statement, you don't have to have an else. Like your switches don't have to have a default. But they can. And they work just like that else block. This is an example of both case R and case C doing the same thing. So this is how you would code two cases with the same block of code doing the same thing. And this is some of the newer stuff that I said I'm gonna swing back to once I can modify some settings on my machine. I'll swing back to this. This is some of the newer stuff with switches. and the newer version of .NET. Like you can see here, C# 9.0 and later. All right. One more coding structure, okay? One more coding structure that we're going to cover today. Okay. This right here, if, else, if, right? Before we got that complex, we just had an if, else. Right, so I'm going to boil this down. I'm going to get rid of the switch. Okay, get rid of my notes. Okay. So at some point today, we said, we had a simple if-else. Right? We had a simple if-else. You might assume correctly that this is going to say employable. Thanks for using my program. Okay, good. So if-else. And then it got more complex. We said if-else, if-else, if-else. Okay. And if-else can be replaced. If-else, this right here can be replaced. So if-else, if-else. Now it's not any more complex than if-else. So it's just an if-else. Remember, what does an if-else do? It's a coin flip. It can run one thing or the other. Okay, true or false. It's a coin flip, 50-50 kind of thing. You know, whether it's going to run one or the other. Now I'm not trying to get into odds here. What I'm saying is sometimes it'll run one, sometimes it'll run the other. I'm not saying that they will execute half of the time 50-50. Okay, you get that point. Let's rewrite this with what if-else can be replaced with a ternary operator. That's a fun word, ternary. Right? Let's talk about binary operators. We've used binary operators. We say int I equals 0, I plus plus. That's not binary, that's unary. Unary meaning one. It operates on one variable. I is our variable. Plus plus is a unary operator, meaning it operates on one variable. It takes I and it makes it go up by 1. Binary operators operate on 2 variables. So you would say int I equals, 2 plus 2. The plus addition is a binary operator because it takes 2 plus 2. Two inputs to get the output. Right? This is called a ternary operator because there's really 3 parts. And so a ternary operator replaces if-else statements. And so I'm going to replace this if-else. So here's the first thing that we do. We look at our expression. Our expression is age less than 100? Question mark. So that's what we're evaluating. We're evaluating age less than 100. If it's true, console.writeLine employable, colon. If it's false, console.writeLine unemployable. And now this is not liking. Okay, so what it doesn't like is I actually have 2 statements in here, so I need to actually write this a little bit differently. It doesn't like that I've got these 2 statements. So how you would actually code this? String employable equals so this is actually assigning a variable based on this expression. So the variable is called employable. If age is less than 100, we're saying employable, colon, if it's false, we say you're unemployable. And then what we would do is we would do a console.writeLine employable. And there you see, functionally, it's the same as an if-else statement. And it's the ternary operator because there's really three parts. It's you're saying, here's your expression, here's if it's true, so this is part 1, this is part 2, and this is part 3. This is what we're evaluating. This is the true block. This is the false block.
Just kind of simplifies it.
It shortens it up, simplifies it. Yeah.
Will it always from left to right be true, false, or is there ever like a time where false will be first?
It's always going to be true, false. Good question. So here, they're evaluating subtotal greater than 100. If it's true, they're setting something equal to a 0.1. If it's false, they're setting it equal to 0.05. And so you can see here they're setting this decimal based on this condition to either 0.1 or 0.05. All right, folks, we have covered a lot in this lecture so far today, and we're only halfway through the chapter. All right, I'm going to stop today's lecture here, and so we can actually start into some lab.